All right. Okay, so let's talk about something we should hopefully feel a little bit better about. Oops, I need a pen. Okay, so I have a resistor here. Sorry, resistor. I have a battery here. Put a resistor here and put a resistor here. And I'm going to make this a 4-volt battery to make my math easy. This is going to be a 1 ohm resistor and a 3 ohm resistor. Now, hopefully remember that since these are in series, the total resistance is blocking it, right? And so we would go the voltage total is equal to the current total. And again, I'm going to get to the point, but just give me a second longer. Is equal to the resistance total, right? And we would get 4 equals I times 4, so I equals 1 amp. Again, this is all stuff I hope you know how to do pretty easily. So then we said, way back when we said that the voltage would drop across this, V equals IR, right? V equals IR. So that would be 1 times 1. So we'd lose 1 volt here. I use the word lose 1 volt here. And we would lose how much going across here? Well, we'd be doing V equals IR. We'd end up with 1 times 3 and end up with 3 volts here. And so Kirchhoff's law says if I start up here and I go in a loop, I'm going to go around in a loop and I go back to that same spot. I have to have the same amount of voltage when I started. So here's what, so essentially voltage difference of nothing, right? I can't have a different voltage. So Kirchhoff's law always says 0 is equal to. Now what happens if I go this way? Well, I go this way, I'm going to lose potential, essentially energy. I'm going to lose energy to go across here. How much do I lose? I'm going to lose a minus IR. Make sense? Hopefully. Yeah. That's handy. And then going across here, I'm going to lose another IR. And then I'm going to go up, since I went through the negative side of the battery to the positive side of the battery, I would get plus 4 volts, right? And so therefore, if I do my math carefully, I would get negative 1 times 1 minus 1 times 3 plus 4 equals 0. And it works, which is nice. But you asked about the signs, and so I just kind of assumed the signs and want to talk about those just a smidge more. What if I went the other way around the loop? What if I went counterclockwise? Well, then it would be 0 equals, so I'm going from the positive end of the plate, the higher energy for positive sources, to the bottom of the plate, I actually lose 4 volts. What? I lose 4 volts. But then I get to the back side and something funny happens. I'm going against the current, aren't I? If I'm going against the current, it means I'm climbing uphill. So instead of having a minus sign, I would have a plus IR and another plus IR before I got back to the finish line. Okay? And so I would get negative 4 plus 1 times 3 plus 1 times 1, and I get 0 again. Doesn't that work out nicely? So Kirchhoff's law sets the signs based on whether or not you are going uphill for potential or downhill for potential. Okay? So I'm hoping that makes sense. Okay? So if I'm going this way around, I'm falling the electrons down through the first resistor, down through the second resistor, and then I take the ride back up through the battery. Right? So this is positive. These two are negative. On the other hand, if I go backwards around this loop, I could say, well, I'm going from the top of the battery to the bottom of the battery. Right? So I lose energy there, potential. But now I'm going to struggle my way up against those electrons. I'm going to gain energy going uphill, gain energy going uphill, and then I'm back where I started. So in Kirchhoff's law's case, the idea is that the signs are set by whether or not you're gaining energy or losing energy. All right? So now we need to talk about just one other thing to make sure that this is clear, and that is what if I have some sort of random arrangement of things? Resistor, I've got another resistor here, I've got another resistor here, and I've got a resistor here, and I've got a battery pushing on this backside, and then I've got a resistor, say, here. So the first step in Kirchhoff is to guess which way the currents are flowing. And you do the math as if that's right. So I'm going to say I1 is this way, I2 is this way, I3 is this way, and I4 is this way, and I5, oh, this is going to be I1 again, this is going to be I2. Now you're thinking, well, it makes perfect sense. Why wouldn't it work that way? And so if I was doing this loop, I did it this way, I would assume that I got 0 is equal to, let's call this voltage V, I1 times its resistor, negative, because I'm losing energy because I'm going the direction of the current. Going this way, I would lose some more, I3R. Going this way, I'm going to lose some more, so I would get minus I1 times its R. These R's would probably be different, but I'm not going to mess around with that right now. Plus, I'm now going uphill in the voltage battery. Or I could do it as if I went the other way around the loop. I would get negative V because I'm going from the top of the battery to the bottom of the battery, potential-wise. And then I'm going backwards against the flow, so I'd have plus I1 times that R. And then I'm going against the flow here, plus I3 times its R. And then back towards this battery, and I get plus I1, or sorry, plus I1 because I'm going against the flow, against its R. Okay? Now, all that works fine. You should be aware, though, we assume the direction of these currents. In fact, one of the problems we do in the class, we have very much looks like this. And this battery is so much bigger than this battery, it's actually shoving current backwards through this one. But as long as you're consistent with your signs, it'll take care of itself. You just have to pick a direction and assume that's downhill. And then if you end up with it going backwards, you just get a negative value for your current. Maybe you picked the wrong direction for the current, and I don't really care about that, okay? So let's do this last loop. Let's do this one all the way around the outside, okay? What would this be? This would end up looking like, starting here, I'm going to start here, I'm going to go, that's the direction I expect to go in, so that's I1R, but it's going to be negative because I'm going downhill. But now I hit this one, it's going to be, it's going to be plus I2R because I'm now going uphill. I think the current's going this way, now I'm fighting it uphill. I'm gaining potential. Then on the back side, I would be going backwards to this battery, so that's going to be a negative V. And then I'm going against the flow, so that's going to be a positive I2R for that one. And then I'm going the direction I expect to go, so that's going downhill. It's following the electrons downhill. So that would be a negative I1R. And then I'm back to the back side of the battery. I'm going uphill on that one, so that'd be plus V for that one. Okay? I hope that clarifies the signs. If it does not, send me another note. And then what I'm going to probably try to get you to do is I'm going to probably try to get you to sign on to some sort of device so we can figure out how to have this conversation together. But for right now, if this solves it, great. If it doesn't, please let me know, and I'd be happy to do some more. Thank you.